So we're here to solve this challenging statue park variation by Palmer Mebane. It has a squares theme, both with the 2x2 half and half regions, as well as some of the ways you can visually see the black and white circles working. Some of the spaces will just be in these corners. We've got these three cells that will always be part of a metamino. These groups will reach out from these corners. One of the first things to consider is actually what shapes are possible out of these corners. And one thing that can happen in this corner is both of these cells outside the 2x2 box get taken and we get a P shape. That P shape would take this cell or this cell, but it will always not take this cell. And the other options are that we have only one of these two cells taken, but then that's going to have to extend into one of the other 2x2 dash boxes. And so you could form an L or you could form an N. But one thing I hope you see is that you will pin white cells in both of those scenarios. So this L, this N pin the white cells off, and that's the same case if we actually came over here and did this in either direction. So while we have P and L as the options in these corners, P must be the option in the upper left corner. That means over here, this isn't a P shape, and this cell is marked off. That now gives this really two options. It takes this cell to form an L, or it takes these cells to form a U, but this has an invalid 1 and 3 split in a half and half cell, so it is the L shape. These get marked off around the pentamino. These, just for connectivity, have to get marked in as white. We have the other side of the half and half boxes now are for sure black. This black comes down, this comes over. This is now a 4x1 stretch. It's not going to be part of an L, so it's part of a Y. This Y is going to take one of these cells, but it's not going to take both of these cells, and so this cell will always be part of another pentamino. And something to note is that where this is one shading or this is another shading, and maybe I can do that in two colors, like this is one way these cells go and this is the other way these cells go. Whether blue is part of pentaminoes or red is a pentamino, over the top here are going to be these cells in white. And I think another constraint that then grows out from that is that we can't actually make a cell like this be shaded, because we'll actually have, let's take this pentamino. So let's go for the blue case. This can grow out to here, but it comes down to here. And so this is white and that's blue. In the red case, this can grow out to here. And again, this is green. And this is now, I just shaded over a blue with a red. So what I think you can tell at this stage of the grid is that this cell here must absolutely be white and this cell must absolutely be part of a metamino, because again, this group has to get out and this will have to extend and dodge whichever sort of part of this Y goes. There's not enough room otherwise. And so we're starting to put some constraints on the top that will be key as we make the next steps. I think one thing you can do with that is actually work off this black circle. While there is a I that could still be placed in the grid, this is blocked off by that white circle, and it can't be for long because the L and the Y are already there. So this can't just come down through the space. It also can't come over here because that would intercept this. So to be able to get 5 cells, it's got to take the 3 in the top row and 2 more from this 2x2 box only. There's no way it can get further out. That now means this channel must be taken for the P. The P being marked means this has to take 2 vertically, whichever it does. But we also now, with this cell marked in black, this cell gets marked in white. So this is how this shape goes. We've got a Y in the grid. And here, I think before I go too much farther, it'll be useful to make some progress in this lower right corner, which we haven't looked at yet. We said at the start where we had a P up top and an L over here. The remaining shape will take one of these cells and form an L or N. L is no longer an option, so this will need to form an N. Notice this N is pretty bad. It would isolate. First, it puts another L up top. It also has a 1/3 split for this half and half cell. So this is taking the other N that can be used, which is this one. It puts this cell marked in the grid to finish this space. This isn't going to be compatible with another pentamino growing out for a set of reasons, including forming an L. So this shape will come into these spaces with one or both of these cells. Notice if I took this cell, I would always have to connect up for an N. So this is a forced unused. And if this is reaching down to take at least one of these cells, this is a forced used. And so these are marked off. And we can't take this cell to actually keep this connected as one pentamino. So this is a forced W shape. And let's actually mark in the ones we have in the grid, W, Y, and L and P in this upper left corner are what we've got. For this shape here, if we don't take this cell, we form an N or a W. Those are not right, so this has to take this cell, which now moves these cells over in green, and this has to take this vertical stretch. Keep this connected so a V is in the top of the grid, and the remaining one will be an F or Z. This has to come over and take these two cells for, again, the half and half rule now that we marked these off, but it can't extend all the way over to be an I, which is the only long one left. There's no 4 in a row one left, so this has to get shaded. If, let's see, sort of some key constraints. I think we've got to do some more elsewhere in the grid before coming back to this. I've not looked at this corner at all, but this is a corner where we're probably going to think about the 2x2 box and say if a cell like this gets shaded, it's not going to be part of this pentomino, but if then this is how this goes, we isolate this lower left part of the grid. So this cell must be outside of a pentomino shape, and that means this cell must be inside a pentomino shape. So we're starting to get a little bit of the definition of this group. If both of these cells are taken, like this, we would form a V or a P. However, we complete the half and half box. And even stronger than that, I think we can say if we take this cell, then if we take this, we now form an N. So this cell is never used. In the case where this cell is used, this would be bad because it would form a P shape. If we take this, we now have a Z or F option. We don't have this L option, but we have something like this that comes across. That looks possible. So there's going to be some tension to still resolve here, but we've got some start of these. Another tension that's now putting is asking, are these two the same shape or different shapes? If they're different shapes, this will have to come up like this. This would come like this. We're going to get a tension where we're starting to form actually an L over here or a P, and that's no good. So these have to be part of the same shape. We can ask, though, are they part of an I? That's the only option that still uses this bottom row. If they're part of an I, these get marked off. This gets for connectivity, and now we actually, for the half and half rule, make a hexamino, so that's no good. So these are part of a small shape that's 3 long and then grows up, and the options that still look to be available of that are a T or a U. The U, though, is no good, so it actually is forced to be a T. So we'll mark these into the grid, get this connection coming through. Now let's come back to the shape. This also had that same constraint of being a U or T, but the T's in the grid, so this now has to be a U. And with that being forced, we now can come back, I think, to this shape and figure out some more about how it's going to go. The key considerations will be how we take two cells up here. And so let's say I don't take this cell. If I don't take this cell, then I'm not forming a P shape, so I'd be coming from and forming the Z, but then I get this little tiny pentomino growing. And so this cell is always part of this pentomino from below. I then can't take this cell because that would form an L or N shape and how those connect. And you can ask, can I dodge taking this cell? So if I don't take this cell, I have another group coming over here like this. And now I have a pentomino growing out that's got 3 in a row, but it can't move up to be a V. The N's in the grid, and it can't come all the way across to be an I. So this can't be part of it. This is part of it. It means this is a Z. In making that a Z, this is an F. And so we've got actually a lot in the grid and can get finished from here. It might have been easier earlier before even handling the Z versus F on the side to think about this and this. And so these can't dodge. They're always part of the same shape. But again, the U and T were being blocked off by these spaces. So the only thing left was a very long connected stretch. And I think you can get this I pentomino earlier than I did. But anyway, after you get the I, get this corner, we're left with our favorite friend at the end of a pentomino puzzle usually, which is an X. There's just one spot left for it. And we finish this puzzle. So really good construction, really clean and elegant from Palmer. It had these forced corners. It had P, L, N as choices. We saw sort of how that played out in these corners. We actually got this to be an L, which made this was an N. After that start, we had a Y interacting with another pentomino shape that would have a limited way to flow off this top edge, and hopefully you got some sense of how to mark some of these cells as forced white and forced black. And in doing that, we got a key constraint that got the top solved, that left behind shapes for a U and T, and got us into the middle and end of the grid for this final X shape. So Pretty challenging solve, but pretty enjoyable throughout. Hope you got something through this video, and we'll see you again soon.